So you might have guessed what the side lengths were for triangle DEF, but the truth is that we can't really tell. We don't see a perfect intersection with any of the grid lines, and so that's why this portion of the question was important. It says expressions for their lengths. So we know that DF is going to be whatever the x coordinate is for point E, right? Whatever the x coordinate is, that is going to be what DF is equal to. But for FE, it's not going to be quite the y coordinate because this triangle isn't sitting on the x-axis. Instead, it's going to be y minus 1. And the way that you can think of that is that we've got a y coordinate, and the y coordinate would be the distance from E all the way down to the x-axis. But if we take away 1, we end up with the actual height of y. And so that's why the y coordinate is y minus 1. Now, we know from triangle ABC that the slope of any triangle that falls along line K has to be 3 over 4. Rise over run, y over x. And so that means that triangle DEF has a slope of y minus 1 over x. Because we don't know what the x and y are, but we know that the y coordinate minus 1 is the vertical distance, and that the x coordinate is the horizontal distance. And so we know that y minus 1 over x is going to be equal to the quotient of the vertical divided by the horizontal in triangle ABC. And I just started question 2, that's using what we know about similar triangles to find an equation for the quotient of the vertical and horizontal side lengths of DFE. And we can do the same thing in the second picture. Go ahead and pause this video and try to label the horizontal and vertical side lengths. They're both y minus something and x minus something. So we know that the horizontal distance is going to be x minus 2, because if you can imagine whatever x is here in this coordinate pair, minus 2, due to this extra gap here, will be the width of this triangle. We have to take away 2 because there's this extra space between the coordinate, or the end of the triangle, I should say, and the y-axis. For y, we also have some extra space, and we can see that the y coordinate minus 4 will be the vertical length of the triangle, because we have these 4 extra units between the bottom of the triangle and the x-axis. And so y minus 4 is equal to the length of the triangle. Now we still know in this triangle, just like the last one, we still know that y over x is 3 over 4. Our slope is 3 over 4. Rise over run, y over x. And so we can take the expressions that we have for DF and FE, y minus 4 and x minus 2, and say that y minus 4 over x minus 2 will be equal to 3/4. Notice that in both pictures, the slope of the line was the same. So we've got 2 equations here, and the slope of the line was 3/4 both times. What changed was the location of the line. The line moved. It was intersecting the y-axis at 1, and now it's intersecting at about 2.5. And so that changed our equation. And so while k and j have the same slope, their equations are slightly different because the location of the line has changed. And that's going to change the equation. Now, the major takeaway from this lesson, which you can follow along with on slide 7, is that we can always calculate the slope of the triangle by calculating y over x. And you can see this same reasoning that we just talked about summarized here, right? We know that for this point E, we are going to have a slope of 2, because in triangle ABC, we're up 2 over 1. So 2 over 1 will be equal to, well, for ADE, the x value is just going to be x, right? This point here is exactly x spaces away from the origin. It's the same, or from the y-axis, it's the same distance as the base of the triangle, but it'll be y minus 1. And the reason why it's y minus 1 is because that triangle ends with an extra unit of space between the base of the triangle and the x-axis. And so our equation for this line is 2 over 1 equals y minus 1 over x. And we can always find the equation for a line by simply setting y over x equal to the slope. The most important thing to pay attention to is whether we have these special intersection points where we're going to need to do a little extra to x and y. There's no new homework tonight, so when you finish up in Class Kick, all that you need to do is make sure you take the exit ticket, which is in today's main folder.